And so we have not done number 5. So we're going to go to number 5 on the calculator inactive packet. And so it says 2 functions are shown below, and it gives you the functions, and it says what's the largest integer value of x such that f of x is less than or equal to g of x. So we want the first one to be smaller than or equal to the second one, okay? Smaller than or equal to the second one. So this is how I would do it by hand, is I would make a chart, and we're going to start with x, and then we're going to have f of x, and I'll move my face in a minute, g of x, and f of x is 1/2 times 2 to the x, and g of x is 5x plus 2. So what we're going to do is we're actually going to pick out some x's and we're going to plug them in there, but I just went in order. So you can start with 0 if you want to. It doesn't matter. I started with 1. So I'm going to plug in 1 to each function. So what is 2 to the 1 power? 2. Half of 2 is 1. I know it sounds dumb, but you can do this in your head. That's what I'm telling you. We don't need calculators. Then I'm going to plug it into the other one. 5 times 1 plus 2. What's 5 times 1? Plus 2 is? We want f of x to be less than or equal to g of x. So we're going to check this out one more time. It says what's the largest integer value. So this works, but it may not be the largest one. Does that make sense? Okay, so let's try 2. So we're going to do half of 2 squared this time. What is 2 squared, or 2 to the second? 4. Half of 4 is 2. We're going to plug in 2 over here. 5 times 2 is 10. Plus 2 is 12. So see how f of x is still smaller than g of x. We're going to keep going. I'm going to go ahead and tell you we're going to jump it a little bit. I would keep going and going and going. I already know what the answer is. I'm going to skip to 5 for a minute. I'm going to do 1/2 times 2 to the 5th. All right, if you have to, remember you have scrap paper. 2 times 2 is 4, times 2 is 8. That's 3 2s. 8 times 2 is 16. That's 4 2s. 16 times 2 is 32. That's 5 2s. So half of 32. 16. Remember, you just multiplied 16 times 2 to get 32. All right, 5 times 5 is 25. Plus 2 is 27. So it's still smaller. So let's try 6. We get 1/2, 2 to the 6th. So 2 to the 5th was 32. Times 2 would be 32 times 2. 64. What's half of 64? 32. So then 5 times 6, which is 30, plus 2 equals 32. What do you notice now? They're the same. If I go to 7, I'm going to go ahead and do it for you. 2 to the 7th. 64 times 2 is 128, divided by 2 is 64. 5 times 7 is 35, plus 2 is 37. Now this one is smaller than the other one. So the biggest one that'll keep it less than or equal to is 6. I think this is the worst problem on this calculator inactive. Just because it gives the largest integer value. That's the hard part. Sorry, I didn't know if it was fuzzy. Okay. So then we did 6, we did 7, we did 8. Go to number 10. This is the next hardest one. This one might be a little harder than the other one. And it's only because it's got decimals. Okay, so I'll show you how this works. It says water is being pumped into a 10-foot tall cylindrical tank at a constant rate. So like a tower, like a farm silo or something like that. The depth of the water is increasing linearly. That means it's adding each time. At 1:30 p.m., the water depth was 2.4 feet. It's now 4 p.m. and the depth of the water is 3.9 feet. What will the depth in feet of the water be at 5 p.m.? So this is what you got to do. They give you, let's see what I did. Okay. At 1:30, we're going to call 1:30 the start or the 0 hour. Water was 2.4. At 4 o'clock, how much time had passed? 3.5 hours, so 3.5. Is it 3.5? Not 3.5. Close. 2.5. 2.5 hours later, it was at 3.9. So we don't need this. This is just how I got these two numbers. So we started at 0. The 2.5 is how long it was from 1 to 4. Okay, 1:30 to 4 o'clock. All right. So then the reason they tell you it's linear is so that you can make a linear equation. We have to do it by hand. Okay, we have to do it by hand. Here's how you do that. We start with our slope. Remember, our slope is our rise over our run, or we do our change in y over our change in x. Your top are your x's, your bottom's your y's. So I'm going to put my biggest y first so I don't have to deal with negatives. So I'm going to subtract my y's 3.9 minus 2.4. And then my x is 2.5 minus 0. You can do these in your head. If you need to write it down so it looks normal, like a regular subtraction. What's 9 minus 4? 9 minus 4, 5. 3 minus 2 is 1. So this is 1.5 over 2.5 minus 0 is 2.5. Now, here's why I think this is really crappy, is because it's decimals and you don't like decimals, right? So think about it as this, 15 and 25. What are 15 and 25 both divisible by? 5. 15 divided by 5 is 3, but it's not whole numbers, it's decimals, so it's going to be 0.3. Does that make sense? All right, what about the next one? 25 divided by 5. 5, so it's going to be 0.5. All right. So then, are you ready? We have y equals mx plus b. We already know our start. What was our start value? Not 2.5. Yeah, it is 2.5, I think. 2.5. 0. Yes, 2.4 is what it is. 2.4 is your start value. I don't like the way I set up my chart, sorry. And then we know that our slope is what? What do we find our slope to be? 0.3 over 0.5? They want to know what time or what is the depth of water at 5 o'clock. So this is where it gets hard. So 1:30 to 5 o'clock. How long is that? (1:30 to 5 o'clock). 3.5 hours. So that's your 3.5. That is your x. So here's your equation. 0.3 over 0.5 times 3.5 plus 2.4. All right, you ready? Here's how you put this together. You're going to multiply. When you multiply fractions, you just multiply straight across. So we're going to do 0.3 times 3.5, and I'm going to do this over here. 0.3 times 3.5. You do it regular multiplication. 3 times 5 is 15. Carry your 1. 3 times 3 is 9, and you have a 1, so 10. But how many decimal places do I need to move? 2, right? Why is it 2? Because I have 2 right here. All right, so 1.05. So what I have now is 1.05 over 0.5 plus 2.4. All right, don't think too hard, a little bit hard, a little bit hard. 105 divided by 5. Forget the decimals for a minute. 105 divided by 5. So 105 divided by 5. If we did it like normal, like you were taught, like elementary school or middle school, I don't know when you were taught it. You move this decimal over and you move this one over. So it would actually be divided by 10.5. How many times will 5 go into 10? 2. Your decimal goes up here. That's 10. You have a remainder of 5. How many times will 5 go into 5? 1. So you get 2.1. So then down here, 1.05 divided by 0.5 is 2.1 plus 2.4 is 2 plus 2 is 4. 0.1 plus 0.4 is 0.5. I think that one is the hardest one just because you have to do decimals. But listen, if you miss one, it ain't going to kill you. Okay? One is not going to kill you. All right? And I think that might finish up this packet. Let me look and see. We did 11. We did 12. We did 13, 14, 15. Good. All right. So we're going to go to the new packet. That one is done. The new packet is another released EOC. So the one we just did in 3 parts was the newest one. Okay, so that's the newest one. And then this one is one from a while back. We're going to skip through it the same way. So I don't mess everything up. Let me do the other one. The first one I don't care about right now. Let's go to not calculator active. Let's flip through till we get to the calculator active so we can work on those. So number 16. And again, we're going to skip around, so we won't do it in order, but we're going to hopefully finish this whole packet between today, tomorrow, and your review day, which would be Friday afternoon. Friday afternoon, we'll start that review, that Zoom review at 1:30. The reason I want to do it at 1:30 is because exams are supposed to be done at 12, but I feel like some of them might take a little longer. So if they do, I want to have time to eat lunch and get my paper stuff together before I have to rush in here and Zoom. So we're going to push it back to 1:30. Zoomers, I hope you heard that. 1:30 on Friday to review. Make sure maybe on Sunday night that you go back over some of this stuff before you take your exam on Monday. Okay. So it's not the whole weekend that you've lost everything. Also, they're predicting some kind of weather tomorrow. We don't know what it is. All right. Have no idea what it's going to be ice if it's anything, but we don't know how much. How about that? So I'll still hold class. I'm taking all my stuff with me. So if you have power, we are having class. If I'm here, we're having class. If I'm at home, we're having class. Okay. If you don't have power, I'm going to record it. So it's not a big deal. You can go back and watch it later. Got it? So everything will be normal tomorrow, just like you were at home. If I don't have power, I will send you an email out through my phone because I won't have to worry about that. And I'll let you know. And if that's the case, I'll try to record something when I do get power, or I'll try to record something on Thursday after my exams because I won't have a review that day. Okay. So I'll do something at some point. All right. For this one, it says, which expression is equivalent to the cube root of 8x squared plus y cubed, or sorry, 8x squared y cubed z to the fourth. So we've done square roots, but we didn't do cube roots. So that just means we're looking for sets of 3. So if I break this down, remember that 8 is 3 2s. We have 2 x's, 3 y's, and 4 z's. We're looking for sets of 3. So there's a set of 2's. There's a set of y's. And there's a set of z's. So those will come outside. A 2, a y, and a z. So if you guys look over here, you see how some of these have fractions or whatever? You guys see that? So the reason they have those fractions is because they're left on the inside. 2, y, and z should not have anything left. Now, this one, I say that, and I'm telling you wrong automatically. All right, so here's what happens. We have x squared and z left, okay? X squared and z left with this cube root. What they want you to do is write it as fractional powers. So right now, we have 2, we have y to the 1, we have z to the 1. How do you write these as fractions? Your power over your root. So cube root, fourth root, square root, whatever. So your x is going to be your power 2 over your root 3. Your z is going to be your power, there's only 1 under there, root 3. I'll show you another way in just a second. It might make it a little bit easier. But then see how we have 2 z's? Does everybody see that? So this is actually 3 over 3 and 1 over 3, which adds to 4 over 3. Okay. I don't like the way that I just taught you, so I'm going to change it in a minute. All right. So look at this. The 8 is fine to do the same way that I just did. Again, the 8 is going to be the 2. They're all 2, so that should have eliminated that in the beginning. You're going to do x to the power over the root. X had a 2 power divided by the root is 3. Y had a 3 power divided by the root of 3. Z had a 4 power divided by the root of 3. What is 3 over 3? What is 3 over 3? 1. So I don't need that power at all. So that's where all the 4/3 and 2/3. So your answer should be this one. So I'm sorry I taught you a jacked up way before I taught you a for real way. We're going to skip 17. It's not that hard, but it's not one I care about. Look at 18. We've had a couple of these where we've had to switch around the formulas, or we had one on the last one and now we have one on this one. If there's one on the last one and there's one on this one that are kind of the same, you can expect that they'll be on your final exam. So we're gonna move around equations. So it just wants us to solve for m on this. So we're going to take this equation, E equals mc squared. And how do I get rid of c squared? I just want m. Don't think too hard. It's not anything crazy. What if I had this? You did this perfectly the other day. What if I'm trying to solve for x? What do? We divide, right? Same thing here. Don't let that square throw you off. We're just going to take it with it. So divide by the thing that you don't want. So what is m equal? E over c squared, which will be d. Okay, don't think too hard about it. All right, look at the next one. The next one I would use Desmos on. Remember, we're on calculator active, so you can do that. Suppose that the equation v equals 20.8x squared minus 458.3x plus 3,500 represents the value of a car from 1964 to 2002. What year did the car have the least value? X equals 0 in 1964. Okay, x equals 0 in 1964. So we're looking for the least value. So here's what we need to do first. 0 equals 1964. So 1 would equal what? What would be the next year? 1965. So this is actually 1. So we're going to mark it out. So then 2 would be 66. 3 would be 67. 4 would be 68. 5 would be 69. 6 would be 70. That's the next one that I have. 7 would be 71. 8 would be 72. 9 would be 73. 10 would be 74. 11 would be 75. 80, I'm sorry, 75, 76, 77, 78, 79, and then 80 would be 16. It wants to know when I plug in X, which one gives me the littlest amount, okay? The littlest amount. And you can do this on Desmos or you can do it in your regular calculator. So I'll show you on Desmos how it works. But I just wanted you to know where I got those numbers from so you didn't think I was crazy. So watch something like this. They try to trick you on that. Watch that. All right. So Desmos is here. We're going to do our 20.8. Our X for A is 1 to the second minus 458.3 times X is 1 plus 3,500. So that gives us 3062.5. So I'm going to put that on my paper. I'm going to switch back so you can see what I did. I just wrote it down. So in 1 year, the value would be 3062. Okay. When we go back here, I'm going to change this to a 6. So the ones will go to a 6. And this value is $14.99, which is smaller. So we can go ahead and mark A out because we want the least value. Now I'm going to go change the 6 to an 11. This is easier to manipulate than it would be in the calculator. You'd have to just keep retyping it in the calculator. So we get 975.5. So that one's the smallest so far. And then we have 16, which will be 1492. So I wrote all those values down. The smallest one is C. That's it. Okay. And again, you guys use Desmos. Good gracious, use Desmos. All right, check this one out. Anytime it says equivalent, you're going to put this into y equals on Desmos. So when I go to Desmos, I'm going to put that first one in. So it's parentheses, just like they have it, x to the, we'll have to use parentheses, 1 divide 3. And get outside of that, to the negative 3. Nope, make sure it goes to the, maybe it is, just kidding. Yeah. So then I like to put y equals, sorry, I didn't put that in the very beginning. I always forget because the regular calculator already has it in there. And then I'm going to start putting in my answers. And it should draw right over that. So square root is on this keyboard down here. Square root x. Did that match? No. So that's not our answer. So we know A is not our answer. We have 1 over x. Did that match? If you're not sure, you can click over here on this color and take it off and put it back on. It graphed right over it, right? So that one is our answer. If we had anything else, x to the 9th, it wouldn't work. And then the other one was x to the 27th, also did not work. Okay. So anytime it says equivalent, where it gives you something equal to each other, do the like the y1, y2. So it was B. All right. Average rate of change, remember, is your slope. And anytime we have a table, I don't like Desmos for a table, so I like to use the other calculators. When you guys come for your exams, make sure you bring your Chromebooks that were issued to you fully charged. If you have your own calculator and you want to use it, you can bring it. You don't have to. We'll get them to you. If you have your own pencils, you can, but you don't need to. So the only thing you're required to bring is your charged up Chromebook. Got it? And mask. Okay, that's it. All right, so here, we know how to put this in our calculator, but look what they ask for. They just ask for week 8 to week 12. So don't put this other crap in. You don't need it, okay? So don't do more work than you have to. So I'm going to go into stat and edit, and if there's stuff in there, just clear it out. There won't be anything in there. There won't be anything in there when you guys get your calculators. All right, so we have 8 and 12. 0.04 and 0.49. And then we do stat, calc, linear regression. And what's our slope? A, B, C, or D? Answer choices. That's okay. D. Remember that A on our calculator. You're good. A on our calculator is our slope. So 0.1125. That's it. So there's a lot of these on there that you can count on. Here's another one. This one just asked about y-intercepts. Dennis compared the y-intercept of the graph of the function 3x plus 5 to the y-intercept of the graph of the linear function that includes the points in the table. What's the difference when the y-intercept of f of x is subtracted from the y-intercept of g of x? Okay, so I know that's a lot. Let's just start with the y-intercepts. How do I find the y-intercept of this equation? Which one is it, 3 or 5? 5. So we're going to start with that. This is f of x. Remember that. So that's the y-intercept of f of x. To find the y-intercept of this, I'll use my calculator and I'll look at B. So we go into stat and edit. And I plug my numbers in. Take a second to make sure you plug them in right. They look good. Stat, calc, linear regression. What's your y-intercept on this one? 5.5. And this is for g of x. It says, what's the difference when the y-intercept of f of x is subtracted from g of x? So we get 5.5 minus 5, which you can do in your head, should be 0.5. If not, put it in your calculator. Just watch what they ask for. We'll come back to 23. It's just writing an equation. It's not too bad. right, look at this one real fast. Monica did an experiment to compare two methods of warming an object. The results are shown in the table below. So this is the first method and this is the second method. So it asked about changing at a constant rate or exponentially. Remember, constant rate means that you add, and exponentially means that you multiply. The one that I want to point out is method 2. How do I get from 3 to 6, 6 to 12, 12 to 24, 24 to 48? What's happening there each time? Multiply by 2. So that one is exponential, right? So let's see what it says. Both methods were at a constant rate. We know that's not the case because method 2 was exponential. Both changed exponentially. We haven't looked at method 1 yet. We'll get back to that one. The temperature using method 2 changed at a constant rate. We know it wasn't. It was exponential. And then the temperature at method 2 changed exponentially. So we need to see if they both did or only 2 did. What's happening each time right here? Pretty much each time. Not 4, but is it 4? It's close to what? 0 plus 5 is 5. 5 plus 5 is about 10. 10 plus 5 is 15, right? So this one is pretty much adding. So the only one it could be is D. We know that this is not multiplying. That's what we know. Okay, let's check out another one. Okay, so this one says Mario compared the slope of the function graph below to the slope of the linear function with an x-intercept of 4/3 and a y-intercept of -2. So then it says, what is the slope of the function with the smaller slope? Okay, so right now, find 2 good points. So let's see, we have one at -5 and one at -2, 1. Slope is rise over run. Your rise was 1. Your run was 3. And it was positive. How do I find the slope of these two? What is an x-intercept? What is a y-intercept? What are they? What's an x-intercept? Your y-intercept is where you start, right? Start on the y-axis. So it's where it crosses the y-axis. So if I had a y-intercept, I'll use a different color or try to. I don't know if this pen's going to work. And I start at -2. What is that coordinate? Like, what's the actual point? Zero, -2. And then if I go to 4/3, 4/3 is 1 1/3. It doesn't matter. I can't really graph it that well. But what would that coordinate be? How far over did I go? 1 1/3 or 4/3? How far up did I go? Did I? 0, just for that coordinate. And then I can put those into my stat if I need to. So in here, now I don't have to do the work. I have 4/3 as an x, 0 is an x, 0 is the y, and -2 is the y. And then I do stat calc linear regression. And my slope is 1.5. 1.5. So which one is the smallest? 1/3 or 1.5? Yeah, if you look, 1.5 is not even an option. Yeah, 1.5 is not even an option. Okay. Let's keep looking. Let's look at 28. I'm going to show you how to do that because I've seen these a lot on the final exam. We can use Desmos. Remember, perimeter is how you add the outside. This is probably the last one we're going to do. It's going to take a little while. Okay, so I'm going to go to Desmos, and I'm going to type those coordinates in. We have 1, 3, comma. We have 2, -3. And we have, I don't think it's putting them in there. I might have to do them separate. Let's see. And then -1, -1. Nope, it made it. Good. All right, so remember to find how far apart they are, it's called the distance of the points. So we have to find all 3 distances so that we can get the perimeter. So the first distance is going to be between 1, 3 and -1, 1. So remember, we type in distance, and we're going to do 1, 3 and -1, -1. And that one is 4.47. So I'm going to write that down, 4.472. Then I'm going to do another point. I'm going to do -1, -1, and the 2, -3. And I'm just going to change this one to say 2, -3. And I get 3.605. The last one I need is 1, 3 and 2, -3. So I'm going to change this one to 1, 3, and I get 6.082. Is everybody good? Remember to type distance in and how you put it in there. So those are the numbers I got. And to find perimeter, I just add them up. 4.472 plus 3.605, 6.082. I got 5.215. Uh-oh, what'd I screw up? Oh, sorry, I have a negative in that 4. I knew something was weird. That's much better. 14.159. So B would be my answer. Sorry, y'all. Helps if you type it in the right way. Let me see if there's another quick one. There's not. We're going to go ahead and stop. I'm not going to keep on. I'm going to go ahead and stop sharing. I have less than a minute left. Stop recording. If you